Hello friends, welcome to Data Science Lovers. In this video, we will build a machine learning project that will predict the electricity demand in a city. Here we have the historical dataset of 5 years and we will use this dataset to predict the future demand of electricity. This is our complete project. Here we have imported our dataset and we have used different functions like datetime function and set the datetime as the index of our data frame, then the describe function, then we have check for missing values and handle the missing values, how to delete a row, how to delete a column, then we have used the ffill method and bfill method, also the interpolate method. Then we will learn how we can create a new column, changing the data type of any column. This is the filtering process. Then we have make use of holidays module, the value count function, and most importantly we have used the lagged features here in feature engineering, the ilog function. Also we have make use of rolling window to find out the rolling mean and rolling standard deviation. Here we have draw the chart for the demand over the time. This is our box plot, our second box plot, and we have drawn the scatter plot. This is our confusion matrix and heat map. Now we have start building our model. We are defining x and y, and we have used the XGBoost model in this project. We are initializing the model and training the model. Then we have making the predictions and visualize our predictions and saving our model in our local computer system. We will import the pandas library for data exploration, data cleaning and data analysis part. Import pandas as PD. We will also import the numpy library because we will make some array here. Import numpy as np, and we will also use the matplotlib library to draw some charts or bar graphs. matplotlib.pyplot as plt, and we will also use the cbone library for the visualization purpose. Import cbone as sns, and here we will also import a random module. This random module will be used to create some random values. Okay, we will run this and all the libraries will be imported in this Jupyter notebook. For your information, the random module provides the functions for generating the random numbers. Now we will import our dataset here. This is our dataset. In this dataset there are multiple columns, and if we see the rows, there are about 43,000 rows in this dataset. So to import the dataset, as you all know, we have to copy its path. I can copy from here also, and I can copy from properties also from here. Copy, and to import the dataset we have to use the pd.read underscore csv file, and here we will paste the path of the file. To remove the Unicode error, we will write a small r here like this. The command has been executed. To have a look at our dataset, this is our dataset. In this dataset we have 9 different columns and about 43,848 rows. The first column here is timestamp column. Here we have date, month and year, and it is starting from 1st January 2020 and it is till 31st December 2024, means about 4-year data is here. Here the information we have is per hour information, or so here is at 1st January 2020 1 AM what was the demand, at 2 AM what was the demand, so like this. The third column here is day of the week. These numbers 1, 2, 3 represents the Monday, Tuesday, Wednesday and all. And the fourth column is month, January, February 1 to 12. And this is the year column, 2020 till 2024. And this is the day of year, means first day of the year or second day of the year. As here we have 366, means 2024 was a leap year. And here we have the temperature record hour wise, you can see. Then we have humidity and we have the demand. So based on this data we will build a model that will predict the demand for the next day, next week or next month. Now let's check some basic informations about this dataset. And to check the information we have the info function like this. It will show the basic information. Here it is showing that the range index are from 0 to 43847. These are the indexes 0 to 43847. By default the index starts from 0. And here are 43848 entries, or you can say records or rows. The data columns are total 9 columns. These are the columns. And it is showing non-null value counts, means how many non-null values are present in each column. In our first column we have 43848 non-null values, which is equal to our actual entries. In second column we have 43842 non-null values, which is 6 less than our actual entries, means in this column, our column, we have 6 null values or missing values. Similarly in our third column we have about 10 null or missing values. Next it is showing the data type of each column. Our first timestamp column is of object data type. Here we will convert it into date time column, and our other columns are of float data type. Let's convert the data type of our first timestamp column to the date time format, or consider our column timestamp equal to, and here we will use our pandas library pd. In this library we will use the toDateTime function, toDateTime, and inside this function we will pass the column name, and this is our column name. I will copy this and paste here, and when we will run this, the command has been executed. If we run the info function again to check the basic information, then you can see that the data type of timestamp column is in date time format now. So it is simple. Next we will set this date time column as the index of our data frame. Here if you see, the index values are starting from 0 to 43847, and now we will change our index and our timestamp column will be changed to our index of the data frame. So let's see how. Here we will use the set index function on our data frame. Our data frame dot set index, and inside this function we have to write the column name which we want to choose as our index. We want to choose timestamp here like this, and we will save the result in our original data frame like this. When we will run this, the command has been executed, and if we have a look at our data frame now, you can see this timestamp column has become our index now, and the total value or the total count of column is changed from 9 to 8. Okay, here if we notice, there were 9 columns and timestamp was present here, but now here we have 8 columns and timestamp is present as our index of this data frame. Now we can use the describe function to check the summary statistics of some numerical columns like temperature, humidity and demand. So to consider a single column, we can write like this in single square brackets, but to consider more than one column we have to write in double square brackets like this. Here we have considered 3 columns. On these columns we will use the describe function and it will show the result. Here it is showing the count, means how many rows or records are present in this column. In temperature we have 43830 and in demand we have 43835 like this, because there are missing values in this data set that we will handle later. The mean temperature is 25 degrees Celsius, the humidity mean is 59 and similarly the mean of demand is 4999 or you can say about 5000. The standard deviation of each column, the minimum value present in each column, the minimum temperature is 3, the minimum humidity is 20 and minimum demand is here, and these are the percentiles and these are the percentiles 25%, 50% and 75% of the values of these columns. This is the maximum value present in each column. 50 is the maximum temperature, 95 is the maximum humidity and demand is 10,715, which is maximum here. In short, if we see, the describe function produces the summary statistics of all numerical columns. It checks for extreme outliers and large deviation, etc. And for categorical data frame, it will show a simple summary of unique values and most frequently occurring values. Now we will check the how many missing values are present in each column using the Enrol function. Our data frame, and on this data frame we will use the Enrol function like this, and we will check the sum of all missing values. So we will use the sum function also with this. When we will run this, it will show the count of all missing values in each column. In our hour column we have 6 missing values, in day of week we have 10 missing values, and we have maximum missing values in temperature and humidity column, which is 18. We can also show those records that contain any null values or missing values using the isNA function or Enrol function, and the syntax will be our data frame name dot isNA. Here I will use any function because we want to show all those records or all those rows which contain even a single missing value. So any, and here I will pass x is equal to 1 because we want the output row wise. When we will run this, it will show the result like this in boolean format, true and false. To get the desired output, we can pass our data frame name and put this command in the square brackets like this. When we will run this, it will show the desired output. These records are those records where we have even a single missing value. In our column, this is the missing value here. In this record, we have missing value in year column, and similarly other columns also, like this one we have missing value in temperature and these all. Here when we see these 4 records, all the values are missing here, means we have to remove these 4 records from here. And as we go down, we can check the result like this. In this row we have this missing value. Missing value is represented as NaN, means not a number. Similarly, we can show all the records that contain all missing values. Okay, so the syntax is almost same. Our data frame name dot isNA function, and this time we will use the all function instead of any function that we use above. Any function we use above, and this time we will use the all function. small a, and x is equal to 1. When we will run this, it will show the result in Boolean format. To get the result in a data frame format, we will pass our data frame and we will include this command in the square brackets like this. It will show all 4 records where each value is missing in every column. Now we will drop all those records that contain all missing values, means we have to remove these 4 records, and for this we can use the drop NA function, our data frame name drop NA function, and here we have to remove the rows where all values are missing, so we will use this function. Here we will use the how parameter. Let's see. First of all, we have to consider our data frame. On this data frame we have to use the drop NA function. Inside this function we have to tell the function what type of rows we want to delete. So in this case we will have to remove the records where all values are missing, so I will pass parameter how equal to all. How equal to all. When we will run this, it will show the result after removing those records. We will save the result in our actual data frame, data equal to this, and this is our data now. Here if we see, we have 43,844 records. Earlier in our original data frame we have 43848 rows. So we can notice that all 4 records are removed now. We can copy this command and run this again. It will show no output because all 4 records are deleted now. Now if we check the count of missing values in each column, again is null.sum function, then it is showing this output after removing the 4 records. Now we have to deal with the missing values of these columns, and for this we have 2 different functions. One is backward fill, the short form is bfill, and we have another function which is forward fill, and it is denoted by ffill. So if we talk about backward fill or bfill, it means suppose we have a value here 61 in this row, and suppose this column has a missing value, means this value is missing, so we have to fill this value with the backward fill. So when we will use the backward fill, this 61 value will also be placed here. Here also we will have 61, means the value is moved, or you can say is copied in the one row above. Okay. Similarly we have forward fill. Suppose this value is missing here, 3012 is not present here, and 3172 is present here. Suppose when we use forward fill on this demand column, this 3172 value will be copied at this place also, means this value will be forwarded in the below row. So this is backward fill and forward fill. Now in this data frame, on some columns we will use the forward fill and on other columns we will use the backward fill. Suppose I will consider some columns here. Our column, on these columns are day of week, month, year, day of year. I will use the forward fill. So forward fill is denoted by ffill, fill function. It is simple like this. When we will run this, the values are filled, but the changes are not done in the original columns. So we have to consider the original columns once again, here like this and equal to here. The command has been executed and the changes has been done permanently. On other columns, the temperature and humidity column, I can use the backward fill function, fill. It is simple. Running this, sorry, data frame is not defined. We have data here. The command has been executed, and we have to save this in our original columns like this, and the changes are done permanently in these two columns as well. Now one column is left here, which is our demand column. On this column, to fill the missing values, we will consider a third function, which is interpolate. So first of all, we will consider this column demand, and on this column I will use interpolate function. In this function we will pass a parameter which is method, and our method will be time here. So when we will run this, the command has been executed. Now let's see what is this interpolate function. The pandas library provides the interpolate method for series and data frames to fill the missing values in the time series data. As we have already this data in time series format, so this function or method will work well here. This method offers various interpolation techniques to suit different data characteristics and requirements. Here we have used the time method. The time method is specifically designed for the time series data, interpolating based on the actual time interval between the observation, and it requires a datetime index. Here we already have a datetime index, so this method is the perfect fit to fill the missing values in the demand column. And we will make the changes in the column here also. The command has been executed and all the missing values in each column are filled now. If we check for missing value is null function dot sum, then you can see there is no missing value in any column. And if we check our shape of our data frame, then we can use the shape method like this. It is showing that finally we have 43,844 rows and 8 columns. Now we will do some feature engineering here. We will create a new column quarter, which will mention the quarter of the year, the first quarter, second, third or fourth quarter. Okay, and we will insert this quarter column after this day of the year column here. Okay, so how to do this? We have to consider our data frame. As you all know, when we create a column, it is always created at the right hand side of the data frame, but we have to insert the column after this day of the year column. So here we will use the insert function, and here in this insert function we have to pass our first parameter, which will be index, where we want to enter the column. As the index of the columns also starts from 0, the OR is our index number 0. This is index number 1, index number 2, index number 3 and index number 4. So we have to enter the quarter column at our index number 5. Okay, so I will pass 5 here. The second parameter, our column name simple will be quarter. In this quarter column we want the quarter from the years, so we will consider the timestamp index here. Our data frame name data dot index. From this index value we have to consider the quarter. So like this. The command has been executed, and when we will see our data frame now, a new column has been inserted which is mentioning the quarter of the year. The January is present in first quarter and the December month is present in fourth quarter. Now in this data frame we can see the values in the columns are mentioned in the float format. We can convert this into integer format using the astype function. So these values are in float format. We can convert these columns into integer format. we will convert the data type of these columns or day of the week, month, year and day of the year into the integer format. So we will consider these 5 columns. On these columns we can use as type function. Inside this function we have to pass int here because we have to convert into integer. When we will run this, we have to pass our data frame name data here. When we will run this, the values are converted into integer. So we will save the changes in our original columns. Like this, the command has been executed and let's have a look. Now here you can see the data type has been converted into integer and this is our data frame now. Now we will create another column which is week of the year, that will represent the week number, means this particular date is from which week and this particular date is from which week of the year. And the syntax as I told above, our data frame name dot insert function, first parameter our index number 5 here, second parameter our column name which is week of year, and third parameter what we want in this column, means the values. For this we have to use a special function which is isocalendar to extract the week from this timestamp column. So we will consider this timestamp column our data. This is our index as you know of the data frame, so we have to consider the index of this data frame. And now isocalendar function, let's see what is this isocalendar function. The isocalendar function is used to extract the ISO year or week number or weekday. Okay, so we have to extract the week number here, so we can pass here week to extract the week of the year, and we can also specify the data type here as type int, means we want the value in the integer format. When we will run this, the command has been executed and this is our data frame now. Here we have the column week of the year. Here it is showing that this is first week of the year. If we expand, what we notice here is this date 29 December is from our week number 52. After this date, the 30 December 2024 is considered in the first week of our next year, which is 2025. So it is showing 1 here. We can confirm this thing from the calendar here also. Okay, you can check this from here. The next thing is we will create a new column to check whether the given date is a weekend or not. So our data frame name dot insert, and this time we will place the column at the index number 7. You can choose any index number of your choice. Okay, and after this we have to mention the column name, and this time we will name the column as is weekend, means the given date falls on any weekend or not. Okay, next thing we will use this index of timestamp, means this date we will use data.index, and from here we will consider the day of week, means Monday, Tuesday, Wednesday or Saturday, Sunday. If I show you in this data frame, the Monday is considered as 0, Tuesday 1, Wednesday 2 and Saturday and Sunday are considered as 5 and 6 respectively. So we have to check whether it is a 5 or 6. Okay, in this index date column. So for this we will use the isIn function, isIn, and here we will mention the value 5, 6, means we want to consider Saturday and Sunday. when we will run this, the command has been executed. Now let's have a look at our data frame. We have a new column is weekend. It is showing false and true, means in Boolean format, and we can change it into the integer format. One method to change the data type of this column was that we can insert HType function here like this. It will automatically give the result in the integer format only, but when we will run this now, it will show error because at index number 7 this column has been already created, so now we can't use this function. So now we have to change this data type in our another line of code by considering this column is weekend and dot HType int. The command has been executed. When we have a look at our data frame now, the values are in the form of 0 and 1. 0 means there is no weekend, and when 1 is present means it is a weekend. We can check this also using the filtering week and equal to, we want those records where the value is 1. Okay, it is for showing in true and false means Boolean, and to get the result in a data frame format we can write like this. So means on 4th January 2020 it was a weekend. Also on 29th December 2024 it was a weekend. Next we can check whether on a given date there is a public holiday or not. For this we have to import the holiday package. Now what is this holiday package? If we see here, the holiday package, it is available in Pandas library. This package offers a comprehensive solution for identifying public holidays across over 80 countries. Okay, so we have to specify our country here while using this package, and it allows users to check if a specific date falls on a public holiday for a given country. You have to mention your country, and you can also mention your subdivision, and it can be easily integrated with Pandas data frame to add holiday information to time series data. So let's see how to add a holiday column. Import holidays. Now using this package holiday, first we have to mention the country for which we want to add the public holidays. I want to add the public holidays for India, and the short form here is IN. After this we have a parameter which is years, means for which year we want to check the public holidays, and here I want to check the public holidays from 2020 till 2024. So simply I will mention this column here, our data frame and year column. Okay, when we will run this, it will show the result like this. It will show all the holidays present in the given years. Now we will save the information in a new column of our data frame. Suppose the column name is holidays only. Holidays equal to this one. Okay, now when we have a look at our data frame, it will show the result like this, where NaN is present means there is no holiday, while other days are holidays. In this project we don't want to use this holiday column, so we will simply remove this column from our data frame, and the syntax will be data.drop and our column name holidays, and we will pass x is equal to 1 because we have to remove the column. The command has been executed. We will save this in our original data frame, and this is our data now. You can use this holiday column as per your requirement. Next we will create some lagged features. What are these lagged features? Let's first understand. These are the past values of a time series data. I will show some example also. What is the use of the lagged features here in this project? Here the past demand values are our strong predictors. Means these values can be used as input to predict future values. The lagged features enable the models to learn from the historical data and improve the forecasting accuracy. Now let's see how to create the lagged features with an example. Suppose we have a data, the sales data, and it is a time series of daily sales from Monday to Sunday, and we created a new lagged features. In this lagged features, we will mention the sales of the last day. Means here we will have a lag of 1. For first value, it will see the sale of last day. As we don't have the sales of the previous day, so we have to mention here 0. On Tuesday, we have to check the sale of last day, means Monday. The sale was 20, so 20 will be mentioned here. Similarly, on Wednesday, it will be 45 because the sale was 45 here, and so on. Here we will have the sale of 50, then 30, then 75, and then 90. So this is our newly created the lagged features with a lag, or you can say step of 1. Similarly, we can have a lag of 2, and it would represent the sales from the 2 days ago, and so on. In this case, we will create 2 lagged features. First, for the demand from the same hour yesterday, or you can say last day, and second feature for the demand from the same hour last week. Our first column will be the data and demand lag 24 hour. Means what was the demand 24 hours ago. In this, we will use the demand column, data, demand. On this demand column, we will use a function known as shift. The shift function is used to create the lagged features. Here we want the demand 24 hours ago. So I will pass a step, or you can say lag of 24, like this. And we will run this, and if we have a look at our data now, this is our new demand lag features, which will show the demand from the previous time point. Here if we expand this data frame, okay, in this column here we have a value of 2716, which is shifted from here the last time point of 24 hours ago, and we have a value of 2302 here, which is shifted from here from the last 24 hours ago. So that's how the lag features are created. Here we have 24 null values because we don't have the data of the previous day. Okay, so whenever you will create a lag features, there will be some missing values or the few missing values in the starting. We will create one more feature here that will show the demands for the last 168 hours, or you can say 1 week. Okay, so data, my column name will be, you can choose any column name. I am choosing here demand lag 168 hours. It will be equal to the 1 week, and here we will consider the demand column again, and this time we will shift the value to 168. Okay, 24 hours into 7 days, so 168 hours for weekly shift. When we will run this, the new column has been created, and if we have a look at our data frame, this is our new column, demand lag 168 hours. In this column as well, the first few rows don't have any value because we don't have the data of the last week from this time series. For first week, it is showing nothing. Let's check the values of this column. Let's say after 168 hours. So I will take a sample using the ilog function. So here we will use the ilog function, and we will consider the only row slicing or record slicing. So we can write our data frame name dot iloc. Here we have to pass the index value. I want to check for index from 168 till we can put any random number till suppose 200. So it will show the values. Let's change this to 160. Okay. Here you can see it is showing the result from 7th January 2020. 168 hours will be completed from this date 7th January. Okay. And if we check here the value, it is not a number, but after completing 168 hours on 8th January 2020, and we will check this row. Here we have a value of 2716, then 2302, and this is the same value if you notice that we have in the first week of the data, 2716 2302. So this is just for cross check purpose. Next we will create two more columns in this data frame. First one is for rolling mean and second column will be for rolling standard deviation. First understand what is this rolling mean and rolling standard deviation. These are the parts of a rolling statistics in time series analysis. Rolling statistics in time series analysis involves the calculation of statistical measures like mean, standard deviation or sum over a moving window of data points. If we talk about rolling mean, then it is also known as moving average, and it is a time series analysis technique that calculates the average of a subset of data points within a sliding window. I will show this with an example in Excel sheet, and this window moves across the time series, creating a sequence of averages that smooth out short-term fluctuations and reveal underlying trends. As in our actual data frame, suppose this is our data for first 24 hours from here. Okay, I will highlight this for first 24 hours, and when I check the rolling mean, or you can say mean of first 24 hours, the mean temperature we can consider here. For this, here it is showing that the mean average temperature is 10.2. okay, we will note it here 10.2. Now we will move our window of this 24-hour from this second point to the next second point. Okay, and here it is showing also 10.2. Now we will move again our window from third point to this third point. Here it is showing that the mean average is 9.7. So this window will keep moving and it will show the result for each subset of our data points. If we do the same thing, the rolling mean for the demand column, then consider these first 24 values. The mean is coming 3809. I will write here like something, and our window will move to the next 24 values, start from here and end till here. Here the mean is coming 3798. 37 and what was 3798. okay, so and it will then move to the third window from here till here, and here this time the mean is coming 3742. Okay, so this is the concept of rolling mean window. Let's create a column for the demand rolling mean for last 24 hours. So my column name here, I am choosing demand rolling mean, and I am choosing a window of 24 hours. You can put any column name here of your choice. In this column, what we want, we have to consider the demand column, which is our target column also, data demand, and on this column we have to use a function which is rolling function. Inside this function we have to pass the window value, means how many values or how many subsets we want to take in a single window. We want a window of 24 because we have hour-wise data, so I am taking 24 here. Okay, and after taking these values, what we want the mean of these values, so we will use the mean function on this. When we will run this, the command has been executed, and if we have a look at our data frame, this is our data frame and the demand rolling mean is now created. Let's see first 27 records for an example. Here I will expand this, and the rolling mean is here 3809. It is the sum of these values starting from 2716 and till 2896, and this is our window of 24 hours. Okay, and for the next values starting from 2302 till here 2433, the mean value will be 3798, and this is equal to our these values that I explained earlier. Okay, similarly we will create a new column that will mention the standard deviation for 24 hours. So my column name demand rolling standard deviation this time, and 24 hour equal to data, and I have to consider demand column again dot rolling, and the window size will be same 24, and this time we have to use the standard deviation function std. Okay, and run this. The command has been executed. Again, if we have a look at our data frame, the column has been created demand rolling standard deviation for 24 hours. This value we expand this, and here this value 959 is the mean, is the standard deviation of for last 24 values. Okay, last, or you can say last 24 records of this data frame, and it is considering the demand column. So from here starting from 2716 it is considering till this one 2896, and it is showing the value 959. In the next window it will take the first value as 2302 and the last value as 2433, and the result will be 975. Okay, so that's how the standard deviation and mean rolling windows will be created. Next part is we will drop all the rows that have the null values. As you can see here, these rows have null values, so we can simply remove these rows to make our model accurate. So our data frame name dot drop na function, and it will remove all the rows having any null value, and we will save this in our original data frame, and this is our data frame. Okay, now our dataset is starting from the date 8th January 2020. You should know why it is starting from 8th January, and the reason is this one, that we choose the column demand lag 168 hours. When we created this column, you remember the values till 7th January 2020, there was the null values in this column, so we have dropped all these columns which is containing any null value, and starting from 8th January 2020 we don't have any null value in any row. Now come to the visualization part here. Okay, we will draw a plot which will show the row demand over the time, and we will consider our demand column for this purpose, and dot plot. Here we will set the size of our figure using the fixed size function, and I am setting it as 15 by 6, and we can also give the title to our plot, and let's choose the title electricity demand over time and plt dot show. So the command is running here and it is the output. It is showing electricity demand over the time from the year 2020 till the year end of 2024. Okay, means December 24. And here we have the maximum demand, and you can notice here about 10,000 megawatt. Let's give the naming to the x-axis and y-axis. The naming given to x-axis is year and the naming given to y-axis is demand in megawatt. After running this is our output. It is year and it is demand in megawatts. Here if you see at the starting month of the 2020, means January, February, March, it is cold, so the demand is less, and as the time or month goes the demand increases, because in summers the demand increases everywhere, and similarly it goes down in winter again and it goes up, and in winter the demand is low and in summer the demand is high in each year. Now we will visualize the demand by hour of the day. For this we will create a box plot here. So first of all, using the matplotlib library, I will set the size of the figure. Now using the seaborn library SNS, we will draw a box plot, and here first parameter we have data. This is our parameter name and this is our actual data frame name. Okay, so don't confuse with it. And we will have our next parameter x-axis. On x-axis what we want our hair. Next we have on y-axis we want demand. Okay, so this is our box plot, and we can give the title to this box plot, and I am mentioning the title here, demand by hour of the day. Okay. Now we can use the plt.show, or we can simply put a semicolon at the end of this command, and after running this it is our box plot and it is showing demand by hour of the day starting from 0 till 23, and it is the demand on y-axis from 2000 to 10,000 megawatt. In a box plot, this upper T represents the maximum value while this lower T represent the minimum value for each hour. Okay, and this strong line represents the median, and this line represents Q1, or you can say quartile 1, means 25% values of the all values are below this value, and this upper line, this one, represent Q3, means the 25 values of all the values falls above this particular Q3 value, and these points you can see here are the outliers. Okay, so after seeing this graph we notice that at 7 p.m. which is 19, we have the maximum demand, okay, from here, and it is about 9,000 megawatt. Okay, and minimum demand is present at 3 a.m. in the morning, which is about you can say 1800 megawatt. So that's how we can read the box plot. Similarly, using the box plot we can visualize the demand by month. So again, use the matplotlib library to set the figure. Then we will use the seaborn library to draw the box plot, sns.boxplot, and we have to give our data. First of all, our data is stored in variable data, so I am passing here. Next we want the x-axis. On x-axis we want month this time, and on y-axis we want demand only, and we can rename the plot plt.title demand by month. Okay, at last plt dot show. So this is the demand by month, and it is showing the months from 1st to 12th, January to December, and this is the demand on y-axis, and this one point is our outlier. And we notice here that in the month of July, or the 7th month, we have the maximum demand, which is reaching about 10,000, while in the month of December here, or you can say in month of January, we have the least demand. And these are the minimum and maximum demand per month, and this is the median. Next, we can draw a scatter plot representing the demand versus temperature using the figure function, setting the figure size 10 by 6, and we will use the C1 library and scatter plot. In this plot, our first parameter is data. Here the second parameter is on x-axis. On x-axis we want to show the temperature. On y-axis we want to show the demand. Here I can use one more parameter, which is alpha. Alpha is used to set the transparency of the points. Okay, so and its value is from 0 to 1. Okay, so I can set a medium value, suppose 0.5. Then we can use the title for this plot also. Here we can give demand versus temperature. At last plt dot show. Running this, it will show the demand versus temperature in the form of a scatter plot. As you can see, as the temperature is increasing, the demand is also increasing, and it is obvious because in summer or in high temperature we use more AC, more cooler, more fan. Okay, and these points are the outliers. When the temperature is about 10 degrees Celsius or below 10 degree, the demand is about 2000 megawatt only, and when the temperature is 30 degrees Celsius, the demand is also increasing, and it is increasing from 3000 to about 6500, and we have the maximum demand here at 50 degrees Celsius of about 8200 megawatt. Next, we will draw a correlation matrix to show the correlation between different numerical features of this dataset. And the correlation matrix is used for understanding the linear relationship between the different features of a data frame. So let's see. First of all, we have to consider our data frame data, and this CORR function means correlation is used to draw a correlation matrix. When we will run this, it will show the output like this in the form of a data frame, you can say, and we can draw a heat map also for this correlation. And first of all, we will set the figure size for the heat map. So I have set the size of the figure as 12 by 8, and now using the C1 library we will draw a heat map for this correlation matrix heat map. Our first parameter in the heat map will be our correlation matrix, this one. Okay, I am removing this from here now, and we want to also show these numbers in our heat map, so I can use a parameter not equal to true. When we will run this, this is the heat map for the correlation matrix. We can make it more readable by reducing these decimal points using the parameter fmt. I am setting it to 2 decimal points, so I can write 0.2f like this. Okay, and plt dot show. Now it will look like this. Here 0.2f means, you can see after the decimal it is showing the value till 2 points only, and not true means it is showing these numeric numbers in this heat map. Okay, now I can set the title for this matrix heat map and plt.title. Here I have set the title as correlation matrix of features. So after running this is our title. Now try to understand this correlation matrix. Here we have our main target variable, which is demand. We have to check the correlation of this column demand with our other columns. The range of the correlation matrix lies between -1 to 1, and if there is 1 means the two features are positively correlated. If the value of one column increases, then automatically the value of second column increases. And if the correlation matrix the value is -1 means the two features are inversely correlated. If value of one feature increase, then the value of second column will decrease. If we check this demand column, it is showing 0.04, means this demand column is, you can say, highly correlated with this hour column. By this correlation of demand and hour column, we can conclude that the demand is highly depending on the hour of the day. Next, if we consider this demand column with the temperature, it is showing 0.83, which is near about 1, means the demand is also correlated positively with the temperature column. As the temperature increases, the demand will also increase. Here also the demand lag 24 hours, and these are the correlation, and it is also negatively correlated with is weekend column and day of the week column. The diagonal of a correlation matrix always show a value of 1. Now this visualization part of this project is also completed, so we can move forward to build our prediction model. As you all know, in any model we have two type of variables. One is dependent variable, means the target variable, and others are the independent variables. The target variable or dependent variable is denoted by y, and here y, let's have a look at our data. At the end of the project, we have to forecast the demand. So this will be our target variable or dependent variable. So our y here will be data.demand. Okay. Now we have to consider the independent variables, and independent variables we can denote with x. From this data frame, one variable is target variable, so our all other remaining columns or variables will be considered as our independent variables, and we will save this in a x. Okay. Now to consider those remaining columns, we will simply drop the demand column from this data frame. Okay. Here our data frame is considered. On this data frame, I have used the drop function. Inside this drop function, I have mentioned the demand column. Here we have to pass another parameter, x is equal to 1, because we are considering the columns here. Okay. When we will run this, the command has been executed, and if we have a look at our x and y, suppose this is our target variable, so this is y values, and our independent variables, these are our independent variables. Okay. To have a better look, simply write x here. So here if you notice, in x we don't have the demand column. Here I have written for your reference y as the target variable or dependent variable and x as the independent variables or features or predictors. Now we will split the dataset into training and testing data with a ratio of 80/20, means our 80% of data will be our training data and rest 20% of data will be our testing data. First of all, we will create our xtrain equal to, and here we will consider this x data frame, this one, and we will use the log function. Inside this log function, we will consider the records till end of 2023. That will be 80% of our total records here. So we will mention the date here 2023 and December 31st. When we will run this, now have a look at our xtrain. This is our xtrain from 8th January 2020 till 31st December 2023. Now I will try to explain this xtrain here. Suppose we have this whole data frame including x and y. These features or these columns are considered as x and this single column demand is considered as y. Now we have to split the data into a ratio of 80/20. We have the records from 2020 till 2024. So we have to split these records in a ratio of 80/20. So in our xtrain, if you see, I have considered from starting till 31st December 2023. So here we will consider from starting 2020 and till the end of 2023, and all the x variables will be considered here, and this area or these columns will be our xtrain. I will mention here as xtrain. Okay. After creating this xtrain, now we will create the ytrain. And for this we will consider the y here, our target variable, and again we will use log function, and inside this log function we will start from our first row and till the again 31st December 2023, which is up to our 80% of dataset. And when we have a look at our ytrain, it will look like this. It is from 8th January 2020 till 31st December 2023, this same date. Okay. Now if we go again here we have this value from 2020 till 2023. 80% of y column is considered as our ytrain. Here we can simply write it is our ytrain. Okay. Next we will create our testing data set, our x test and y test. First create the x test. For this we will consider our x data frame. Again we will use the log function, and here this time we will use the data from starting of 2024 till the end of 2024. So here we have to mention our starting date, and our starting date will be 2024 and January and 1st January. Okay. When we will run this, here by mistake I have typed the testing dataset, but in actual it is training dataset. Okay, 80% is training data, so change it here training data. Okay, and this is x test is our testing data, and it is 20% of the dataset. Okay, 20% of our dataset as testing data. Now if we go here again, this x test is this much area. Okay, from starting of 2024 till the end of 2024, it is 20% of our total x. And again I can write here x test. Okay, show the x test like this. It is considering from 1st January 2024 till 31st December 2024, which is our this dataset, and it is 20% of our actual dataset. Similarly, we will create our y test. For y test, we will consider our y variable y dot log function, and on this log function we will mention again the date from where we want to consider, and we want to consider from 2024 and January 1st, and colon, after colon we will keep the blank to consider all the records till the end of this data. Run this, and this is our Y test from 1st January 2024 till 31st December 2024. This is our Y test. Okay. Now we have X train, X test, Y train and Y test. We can check the shape, print, and X train dot shape. It is total this one, and similarly Y train shape, it is this one. Okay, and similarly we can check the shape of test dataset, X test and Y test. It is our 80% of data and it is our 20% of data. Here we have 34,892 records and 14 columns, while in Y train we have only 34,000 records and there is only single column which is Y itself, so it is blank here. Similarly, here we have 14 columns and in Y test we have single column, the Y itself. Now we will use the XGBoost model here for the forecasting, because the reason is simple. XGBoost is a powerful algorithm for the time series forecasting, as it can handle the non-linear data easily, and it can also handle the seasonality and trends in the time series data effectively. First of all, from XGBoost library we will import a class known as XGB regressor. XGB, it is running here. The command has been executed. In simple terms, you can say from the toolbox, which is XGBoost here, we are importing a tool which is XGB regressor. It is a class and it is designed for the problems where we have to predict a continuous numerical value. Next is from sklearn library we will import two fundamental metrics, and first one is our mean squared error metric, mean squared error, and our second fundamental metric is mean absolute error, mean absolute error. These two metrics are used to evaluate the performance of our model. We will run this again. The metrics are imported now. Next is from the sklearn library we have a module called model selection, and from this module we will import a class, the time series split, and run this, and the class is imported now. This time series split class performs appropriate cross validation when we deal with the time series dataset. Next, we will initialize and train our XGBoost model with some specified sets of hyperparameters. Start with model XGB, and here we will make use of this XGB regressor class, XGB regressor, and here we will pass our hyperparameters. Our first hyperparameter will be n estimators, Here we will set the number as 1000. This hyperparameter n estimators defines the number of trees that the model will build. Here the range should be from 100 to 1000 only, because too high range will lead to a problem of overfitting, while too low range will lead to a problem of underfitting model. The next parameter we have here is early stopping rounds. and we will set it to a value of 50. This is a regularization technique that helps prevent overfitting of the model. Our next hyperparameter is learning rate, and we will set our learning rate at 0.01. The learning rate, denoted by this symbol, is a hyperparameter that determines the step size taken during the optimization process of the model. In simple terms, the learning rate determines the contribution of each individual tree to the final prediction. A smaller learning rate might be slower, but it will show more accurate updates, while a higher learning rate can speed up the training but may lead to the overfitting problem. Our next parameter is random state. The random state, and we can set it as 42 here. Setting a random state ensures that the same sequence of the random numbers is generated each time the model is trained. Our next parameter here is objective, and we will set it like regression and squared error. This parameter specifies the loss function to be minimized during our training. And this item, regression squared error, here indicates that the model is being trained for a regression problem, where the goal is to predict a continuous numerical value, which is our demand column or the target variable. And now we will run this. The model has been initialized. In short, we can explain this above code like this. The XGB regressor initialization creates a model that will train up to 1000 boosting rounds or 1000 trees, but it will stop early if the performance on a validation set doesn't improve for the 50 consecutive rounds, which are decided by our hyperparameter early stopping rounds. Next, each tree contribution is scaled down by a learning rate of 0.01, means the learning rate is set as 0.01 here to prevent the overfitting of the model. And at last, this model is designed to minimize the squared error for the regression task. Now let's start training our model. Here model XGB dot fit function we will use. Inside this function, first of all we will pass the xtrain, then we will pass ytrain. Xtrain and ytrain we have defined above. The next parameter is to provide the evaluation sets, and eval set equal to, and this parameter provides the evaluation sets that XGBoost model uses to monitor the model's performance during the training. Here we have two evaluation sets. First one is xtrain, ytrain, and the second set is stest and ytest. This is our first evaluation set and this is our second evaluation set. And the last parameter we can set as verbose equal to false. Setting the verbose equal to false means we don't want to see the model running here, or we don't want to see any message during its running process. And we will run this now. The model is been running. So this is the output, and our model is ready now for the prediction tasks. Let's create a variable that will store the output of our prediction, and this variable name can be of your choice. I am naming it as prediction XGB. Now I will make use of my model that I trained above, model underscore XGB, and on this model I will use the predict function to make the prediction, and this time we will predict the data from X text. Okay, now we will evaluate our model with these two evaluation metrics that we import here, mean squared error and mean absolute error. So I will create my first variable root mean square error for this XGB model, and here in this I will make use of NumPy library to make the square root of our first matrix mean squared error. I will copy from here mean squared error and paste here only like this. Okay, and here in this we will have our y test and our predictions, this prediction variable. Second, I will create another variable mean absolute error for this XGB model, and in this I will make use of my second matrix mean absolute error. I will copy this and paste here, and inside this we will make use of y test and again this prediction variable. We will run this. The command has been executed. Now let's print the result of RMSE and MAE like this. Okay, so our RMSE value is coming about 167.67, while our MAE mean absolute error is coming about 125. Here the RMSE value is higher than the MAE value, which is a common occurrence. Now the final step is we will visualize our predictions. Using Matplotlib library, first set the size of our figure. Here we will draw two different plots, one for the actual demand and second plot for our predicted demand. So plt.plot, first create a chart for our actual demand. For this, on x-axis we will consider our index from the y test. Okay, and on a y-axis we will consider the values from y test, and we can also give the label to this chart like actual demand, and let's give a color, suppose blue. Now if I run this, then it will show the output like this. We can use plt.show here. Okay, so this is our actual demand in our testing dataset that starts from 1st January 2024 and end at December 2024. Next we will plot the predicted demands. So plt.plot, on x-axis the values will be same, y test, index, but on y-axis this time we will mention the predicted values, and our predicted values here from this one. So I can simply copy this and paste here. Okay, and we can also give the label. Let's set the label as XGBoost predicted demands, or you can say simply predicted values or predicted demand, whatever you want to choose. And this time we will give the color to red to differentiate easily, and when we will run this, you can see the blue color we have the actual demand, while in red color we have the predicted demand. and we can change the line style of this predicted demand. Suppose we can give it as hash. Okay, like this. We can also give the title to this plot, plt.title XGBoost electricity demand prediction. Running this is our title. We can also mention our X label and Y label. Suppose our X label is, we are setting as date because date is mentioned here, and on Y label we are mentioning the demand. Running this, here we have date and here we have demand. We can also set the legend here, plt.legend. Okay, legend function. So here we have the actual demand denoted by blue color, while the predicted demand is denoted by the red color. From here we can easily notice that our predicted demand values are approximately equal to the actual demand value. So means this model is working well. Finally, we will save our model, and to save the model we will make use of the joblib library, and we will import this, import joblib. Okay, from this joblib library we will use the dump function. Inside this dump function we will pass our model name, and our model name here is model underscore XGB. We can copy and paste here. Next we have to mention our file name. I am giving file name as electricity XGB prediction model. You can name anything, and here we will use the extension pkl. Okay, when we will run this, the command has been executed and it is showing the output like this. We can locate this file on our computer system. Here if we see in this folder we have this model, electricity demand XGB model.pkl extension, and it is showing that the type is pkl file. pkl is the short form for pickle file. Now whenever we want to use this model for prediction, we can simply load this in this Jupyter notebook and use this. And this is how we can load this model. Using the joblib library, we will use the load function. Inside this function we will pass the file name, the pickle file name that we saved above. Okay, so that's how we can load this model, and the model is loaded. And if we run this, it will show the output like this. Okay, so that's all friends for this video. I hope that you have learned too many things from this project and you will implement this project in real time. Thanks for watching.